Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm specifically going to look at how we can arrange electrons in various electronic configurations, and of course give a specific orbital diagram for various elements which we're going to witness, in the periodic table. Now in this case, I mentioned from our previous discussion that the concept of orbital diagrams are basically going to be a specific arrangements that are going to show electrons in or arrangement of electrons in an atom. And of course, these arrangements are going to be following a specific order of energy levels, sub-levels, and subsequently the concept of orbitals, which we had looked at. Now, there are specific rules which we had said, of course, which are going to dictate on the arrangement of electrons in the these orbital diagrams. And of course, this was the Hans rule, Pauli's exclusion principle, and the concept of Aufbau's principle, which of course dealt with the concept of building up of these energy levels and sub-levels. Now, in a sense, I had given a specific arrangement, which was going to assist us in trying to, of course, try to make up these orbital diagrams and electronic configurations. And of course, this was in terms of this a specific representation where I said that we can represent various sub-levels using this particular order, whereby we're going to have this one represented for the S, P, and of course D and F, of course sub-levels given as such. So in this case, the first column represented the concept of this S sub-level, and then we're going to have orbitals which are going to be for the P sub-levels given as such. And then we shall have the D sub-levels given as such. And then lastly, we had said that we're going to have the F sub-level given as such. So in this case, we had said that we can use this particular arrangement whereby we're going to start from the lowest sub-level in terms of energy given for 1s, 2s, and that's going to go in that particular order, whereby we are going to have the arrow indicating the movement, or rather the order in which we are going to organize these particular electrons in the various sub-levels given as such. So in this case, subsequently, then therefore we had mentioned that we can give an example of an element which I gave for oxygen with an atomic number of 8. And therefore I said that we can organize this one in terms of an orbital diagram or an electronic configuration given as such. Now the difference between the two is that the orbital diagram is going to be particularly showing what we call their specific spins, whereby we say that for oxygen, which is going to be arranged in this particular order, whereby we are going to have the 1s orbital followed by the 2p, the 2s in terms of energy, and then we're going to have the 2p orbital given as such. So this specific arrangement can be given in terms of the various orbitals which we had said, whereby we said that an orbital is going to have a maximum of 2 electrons, and therefore for the p orbital is going to consist of the 3 degenerate orbitals for the x1, z, as I said for that specific example. And then we are going to have these electrons being arranged. Of course, I'm going to fill this one just for the sake of a summary. So we're going to have these electrons filled according to Pauli's exclusion principle, and then we're going to have the opposite spin of this next electron. So this is going to have us a total of 8 electrons, and therefore that's going to constitute what we refer to as the orbital diagram. In this case, to contrast that one with the electronic configuration, we had said that basically for electronic configuration, this is going to show electrons without their orientation. So we're going to have the first 1s orbital having 2 electrons, 2s orbital having 2 electrons, and the 2p orbital having 4 electrons given as such. So basically this is going to be, the electronic configuration is going to be basically a summary of the orbital diagram, which is going to assist us try to identify the arrangement of electrons of an atom given as such. So this shorthand form of orbital diagrams are going to be electronic configuration, which, as I've said, are not going to be showing specific orbital or the specific spins of electrons, particularly being shown for the orbital diagrams given as such. Now, I mentioned that we can use a shorthand form in trying to represent this electronic configuration, and this, of course, was to be using the concept of noble gases, which are going to be assisting us in trying to write a summary of electronic configuration of these various elements. Now, this is particularly the case since these noble gases are going to be having their S and P, of course, orbitals being full, and therefore this is going to be assisting us in trying to represent the inner shells of these specific atoms, especially for various elements, using the concept of these noble gases. Now, particularly, perhaps I can just give an example of this specific arrangement, whereby we're going to use an example of bromine, which is of course a group 7 element given as such, and this is going to be having an atomic number of 35. So for us to try and make an electronic arrangement for this, we're going to use a noble gases that is going to precede bromine in the periodic table, and that's going to be catering for the inner, of course, the shells which are going to be, of course, the S and P shells which are going to be full. And as we had said, of course, these are going to constitute what we refer to as the valence electrons, which are going to be contained and the S and P shells. Now, in this case, in trying to represent the shorthand form, this is going to be appearing in this specific format, whereby we're going to have a bromine. So perhaps we can just do away with this. So we're going to have this arrangement for bromine being given in full. So we're going to have bromine 35 being given us. So we're going to have the 1s orbital, 2s. So basically we're going to have the 2p, and then we shall have the 3s followed by the 3p, followed by the 4s, followed by the 3d, and then we shall have 4p. So let's try to fill up that one. So S contains, NS orbital is going to consist of 2 electrons. So we are going to have this one, 2 electrons given as such. P orbital is going to consist of 3 electrons, and therefore that's going to be filled up with a maximum of 6. So in this case, this is going to be 6, 6, and then we shall have 6 given as such. And then the D orbital is going to consist of course, 5 orbitals, which are going to be 10. So we are going to look for a number, the subsequent filling of orbital from the low energy level, which is going to give us a number closer to 35, which is basically, so this is 10 to 2p orbital, this 10, it's another 10, which is up to 4s orbital, and then of course that's going to form that here, that specific point. So we shall have this one being given for the subsequent element. Now in this case, we are going to look for the last, of course, what we refer to as the last S and P, which are going to form the valency configuration, whereby we have the 4s and the 2p orbitals, which are going to be given as such. So in this case, for 35, of course, we understand that this is going to be consisting of, this is 10, 20, 30, 36. So there's an extra electron which is here. So we are going to have this one consisting of 5 electrons. So therefore, this full representation is going to give us a representation for bromine 35 atom being given as such. So for us to indicate using a shorthand form, we're going to look at the noble gas, which is going to be given using or preceding bromine, and this is going to be argon, which is going to have an atomic number of 18 given as such. So the difference between 18 and 35, of course, that's going to be a difference of 17. So therefore, the 17 electrons are going to be contained in this other arrangement for the orbitals, and with in addition to the electrons contained by this noble element 18 for argon, we're going to have this one represented by the other remaining orbitals. So in this case, for us to have this specific arrangement, so we're going to have the first 10, and then 12, 18. So from this specific section to this one, this is going to represent the element for argon, and the remaining ones are going to bear the other, of course, designation for the various orbitals for the SD and P given as such. So for us to represent a bromine in terms of this shorthand form, we're going to have this one given in square brackets given as such, catering for the 18 electrons, and then we shall have the 4s2, 3d10, and 4p, 5 orbitals are given as such. So there is an additional rule which we are going to, of course, conform with, which is going to require us to represent only the valency electrons, or we can give it this one in terms of a valency configuration, whereby we said these valency electrons are going to be contained or consisting of the S and P, which are going to be taking part in, of course, what we refer to as reaction. So in this case, we are going to have this one represented in terms of valency configuration. So this electronic configuration in terms of course, this specific orbitals, which is going to consist of what we call electronic configuration, which is, of course, a shorthand form of the orbital diagram. The orbitals shows the orientation. This one does not show the orientation. And of course, this is going to be using a noble gas form to show the shorthand form. And of course, we can have this one using the valency configuration by trying to show the S and P, of course, configuration given as such. And this, of course, is going to be referred to as the valency configuration. Now, therefore, bromine can be written in terms of the valency configuration using the P, which is equivalent to 4s2 and 4p5 given as such. So in case we come across those various terms for the orbital diagram, electronic configuration, the shorthand form using the noble gases, and the valency configuration, then therefore we're going to create a contrast between the various forms which I've mentioned. Now that's going to form our final picture concerning the orbital diagrams and the electronic configuration. Now in case we come across them in our various discussion, I hope that they're going to be handy for us in trying to understand various electronic arrangements for different atoms across or down the periodic table. So that is it for now, guys. By God bless you. Catch us in our next video.